Rational exponents and higher order radicals. So if we have this rational exponent, right? Because the exponent is a ratio, it's a fraction, okay? 512 to the 4/3 power. So to simplify it, I guess you could try to go for it with a calculator, but let's see what we can do here. This is 512 to the first power times 512 to the 1/3 power. Okay, because look, this is 1, right? And which is, in other words, 3 over 3. If you multiply a number times another number with the same base, the exponents would add, right? If you did x squared times x to the third, that makes x to the fifth. So 512 to the first times 512 to the third, that makes 512 to the 4/3 because the powers would add. Okay, and so what that allows us to do is that 512, and this came from a bit of intuition from just being a math teacher, okay, but 512 to the 1/3 power, that's cube root, in other words, okay? Or you could do it like this, 512 raised to the 0.333, 1/3 power, and it's going to make 8, okay? So we got 512 times 8, that makes 4096. So that one, if you punched 512 to the 4/3 power in your calculator, you would have got it too. Okay, but that's how you could do it without a calculator. 512, I just knew that we could find the cube root for that just from seeing it so much from math experience. So I understand if maybe students don't spot that right away, We want to do the same type of thing with this one. 125 to the 2/3. Check this out. How can we write that as 125 to the first power divided by 125 to the 1/3 power? Because if you have x to the 6th divided by x to the 2nd, the powers subtract to make x to the 4th, right? So x to the 125 to the first subtracted by 125 to the third. The 125 is to the first power. The 125 is to the 1/3 power. So 1 minus 1/3 makes 2/3. Okay, so I took it and I rewrote it in terms we can understand better, because now 1/3 means cube root. Okay, so you can get 1/3 in your calculator by typing in 125 and then hitting that cube root button. So the top is just 125 to the first, the bottom is 5, so we get 25 for our answer. So that's really what they want you to practice in this, because when you have it as algebraic expressions, it's not quite as easy, right? All right, yeah, because now we got finally got variable going on here. Okay, so we got 4 over the 7th root. That's what the 7 means when it's there in the radicals. So that's x to the 5th. Okay, so what radicals are? They're fraction powers. Okay. So this is 4 over x to the 5th to the 1/7, in other words. Okay? So a way we can simplify this is x to the 5th to the 1/7. A power on top of a power multiplies. So that makes x to the 5/7 power. Okay? And then we also have another property. If you have 1 over x squared, that's the same thing as x to the -2nd. That's what negative exponents mean. Okay? So another way of rewriting this with no variables in the denominator, it's 4x to the 5/7. Sorry, negative, right? Because we moved it from the denominator to the numerator. So let's see if we can find any that match up here. We got 4x to the -5/7. That's the one we want. Okay, and then we got 13t to the -16 over 7. Now, like we just said, negative exponents, you can switch their sign by moving it from the numerator to the denominator or vice versa. So this is 13 over t to the 16/7 here, in other words. Okay? Or another way to write it, if you want to have the radical symbol come into play, it's the fraction, the denominator of the fraction is 7. Okay, so that means you could put the 7 outside the radical symbol right here. Okay, and 16 goes on the inside. Because remember what we just saw is that the 7 means it's 1/7 power. This is t to the 16th to the 1/7 power. And that would multiply to make 16 over 7 like we just had over here, and then you could reverse it. So all these steps are equivalent to one another. So let's see which one matches up. What do they want? 13. Oh, that's the one we wrote.